In this video, we're going to be talking about what atomic mass is and how to calculate it. Atomic mass, also called average atomic mass or relative atomic mass, is the average mass of an element based on its percentage abundance of its isotopes. Remember, an isotope is just an element with a different mass number. So a common example would be carbon 12 is one isotope and carbon 13 is another isotope. See that it's the same element but a different mass number, and recall that mass number is protons plus neutrons. So it's the average mass of all the isotopes averaged out. So we're going to do some example problems and just a few hints before we get started on these. First of all, whenever I have an element, like an actual element that's on the periodic table, when we calculate the average atomic mass, the answer can be found on the periodic table. So for chromium, that is an actual element on the periodic table. So if we go to find chromium, it is located right here. And let's zoom in. This number right here is the atomic mass. So our answer is going to be, literally, it is going to be this number. So whatever answer we get, we know it's going to be this number or very, very close to it. There might be some rounding involved, so it might not be exactly that number, but it should be pretty darn close to that number. So we have an answer key in the periodic table in any time we have an actual element that we're calculating for relative atomic mass. So chromium, we're going to do this problem, and we know the answer is going to be approximately 51.99. All right, so let's go ahead and start solving this. So the question is asking, and then one other clarifying point. We see here that the numbers that we are using are, we have chromium 50, chromium 52, chromium 53, and chromium 54. I did a terrible job circling those, so let's highlight those instead. So chromium 50, in fact, I'm just going to highlight the mass number by itself. So 50, 52, 53, and 54. Keep in mind that an average is the average number between two or more values. And we emphasized when we talked about this that it is between those values. So if this is a multiple choice question and any of the answer choices is below 50 or above 54, you can cross those out right away, because it is impossible to get an average that is less than the lowest number or greater than the highest number. So the average always falls between the range in the numbers. That's really important and very valuable in double checking your answers. All right. And then furthermore, we could look at what the highest abundance is and say it's probably going to be closest to that number. So the highest number highest abundance is chromium 52, so it's probably going to be closest to 52. And if we check our answer, which we haven't even calculated yet, but remember the answer is given to us, we said it's going to be closest to 52, right? Because 52 is the highest abundance. Let's see what the answer is going to be. 51.99. That's pretty darn close to 52, if you ask me. All right, back to solving it. We got to work on how to solve it in case you have to actually solve it instead of looking at it on the periodic table. So this is a great example for us. Let's get started. So anytime we're given a percentage, we need to convert these percentages into a decimal and then multiply it by its mass numbers. So we said 50 We're going to take 50 times its relative abundance, which is 5.8. 50 times 5.8. But we need to convert 5.8 to a decimal first. How can we do that? We're going to just move the decimal over 2 spots to the left. So 50 times 0.058. Then we're going to add the next one. We've got 52 times 0.838. Remember, we moved the decimal over 2 spots, or divide by 100, whatever makes most sense to you. And then we're going to plus the next value. We've got 53 times 0.094. And then I'm running out of room, so I'm going to make this a little bit smaller. Or maybe just move it over and make it a little bit smaller. All right, and so 53 times 0.094 plus 54 times 0.01. We're going to type that all into our calculator, and then we're going to get a value of 51.998. All right, we said it was going to be pretty close to 51.996. That is pretty darn close to 51.996. There's some rounding involved, and there's other reasons that's kind of beyond the scope of this class. But the answer should be pretty close to what's on the periodic table, and this is pretty close. Now, what units do we need? Because units are extremely important in science. The units are atomic mass units, abbreviated by AMU. All right, as we said, the answer happened to fall between 50 and 54 because those are the lowest and highest values. And then also, we can double check our answer by saying it makes sense because it is closest to the value that has the highest relative abundance. And that is that is always the case when we have only 2 numbers, and it's usually the case when we have more than 2 numbers, but sometimes it's not. But something that's always the case is it's always going to be between the highest and lowest values, so always falls within the range. For this next one, I have an elements x here. So instead of having an elements that's on the periodic table, where we actually know the answer prior to solving it, because we can just look up the answer underneath the element on the periodic table, we actually have to solve the answer here. And so we're going to solve it the exact same way, but we just don't get to double check our answer to know absolutely certain what it is. But we can use those other methods of double checking our answer by making sure that our answer is between the range of the values, and also by checking to see if the highest relative abundance, if the answer is closest to that number, which is typically the case. It's always the case if there's 2 numbers, and typically the case if there's more than 2 numbers, but sometimes it's not. Here it will be. Anyway, go ahead and pause the video and attempt to solve this one on your own. Again, we're going to solve it the same way as we did the last problem. All right, here we go with solving it. We have our relative, we're calculating relative atomic mass. And so first I'm going to highlight the mass numbers. So we have 241, 242, and 243. All right, and we said that 0.8% of all element X in the universe exists as X241. So we need to convert everything into a decimal. So 1, 2, move the decimal over twice to the left for each one of these. 1, 2, and 1, 2. All right, so we are going to start plugging these in. So we've got 0. We're going to do the mass number first. So 241 times its respective frequency or relative abundance. So 241 times 0.008 plus 242 times 0.012 plus 243 times 0.98. We're going to type this all into our calculator, and we will get a value of 242.972. Let's double check and make sure that answer makes sense. First of all, it doesn't make any sense unless we have units, so we're going to put our units of atomic mass units, AMU. Next, we're going to double check to make sure it falls between the range. So is 242 higher than the lowest value? Yep. Is it lower than the highest value? Yep. So therefore, it is a reasonable answer. And then lastly, we could say, hey, we have the highest relative abundance is 243. Our answer should probably be closest to that value. So 242.972 is pretty close to 243. So that also passes that check for us. I would say that this is a reasonable answer. We can circle it and move on to the next question. But that's all I got for a review. So hopefully that helped. Study back through the original material if you need more practice. But that is atomic mass for us.